So now since we uh, made some, made some progress or good progress in understanding essential components of C programming language, so we have to revisit this idea. Okay, so there is a problem that we would like to solve. There is a problem that we would like to solve. So real world problem. There is a So when there is a real world problem that we would like to solve using computer, so the first important thing that is required, what is the first important thing that we should do in this process of solving this problem using a computer? Algorithm. Okay. So the first important problem is we need to model this problem, build a computational model for this problem, build a model. When you try to build a model of the problem, like uh, the kind of model that we would like to build, it depends on what we are planning to do with the model. Like for example, if there is a building, you want to build a home, then if you want to build a home, there are multiple models of your home that are possible. So one could be a structural model of your building, like which kind of tells you, so where will the beams go, and what are the load bearing components uh, that are there, foundations, things like that. Another model could be a floor plan. Another model could be, a 3D model of your home, so that finally after you build the home, how the home should look like. So when you think about it, that model, you will see, the color of different walls, and where furniture goes, and all those things will be there in the model. So the problem is the same, but depending upon what you would like to do, or there can be a drawing in which clearly where electrical lines are going. There can be a drawing for plumb lines, like which shows where plumb lines are going. There can be a landscape drawing, a landscaping drawing for your home. So for the same entity, depending upon what you would like to do, you may want to have a different model of the underlying system. And uh, and uh, and then when you have a model, you need to have a model representation in the system. You need to have a model representation. Like for example, no, for the home, you decide to represent, you have a 3D structure of your home. You need to represent that 3D structure of your home. And once you have the representation, maybe you want to do different things with your model. Like for example, what will happen if I change the color of this wall from blue to green? How does this look like? Okay. Or what will happen if I change the texture of this wall from this to this? How does the model look like? So that is the algorithm part. First part is the model part. Just give me a minute. So when we take this and look at it from the simplest perspective, so we know, like in the beginning we took up this example. Let's say if you are working with the problem is we are trying to find the roots of a quadratic equation, ax square plus bx plus c is equal to 0. So we want to find the roots of this quadratic equation. So let's think of this as a real world problem. And this equation you may have derived from something else. Okay, there is something that is there, and while trying to solve something, you came up with this quadratic equation. Now we want to solve this quadratic equation to know its roots. So what is the first step in solving this problem? That is finding the roots of a quadratic equation. What's the first step? Determinant is greater than 0, b square minus 4ac is greater than 0. What else? We may draw its graph. Any more answers? Need a way to store it. Yeah, exactly. How do we represent this? Polynomial representation. How do we represent this? This is this is the data model. So data representation. So what is the representation of this polynomial? So we can represent this polynomial by just storing the coefficients a, b, c, for example. The coefficients. So if you fix our attention to only quadratic equations, then we don't need to know the store the degree. We just need to store the coefficients if you confine ourselves to quadratic equations. So after that, what's the next step? So no, yeah, we want to store ABC. What's the next step? So the next step is, can someone tell me input values of ABC? You're all too fast, but you want to know whether what kind of data type you would like to use to store these variables ABC. You want to use an int. So again, if you take an integer, so there are multiple options are there. You want to use unsigned integer representation or signed integer representation, or you want to use no, there are three kinds of int are there. There is a short int, there is a regular int, and there is a long int, for example. So what is the integer? So or do you want to use, so which one we should use? Or do you want to use float, or you want to use double, or you want to use char? So what is the data representation for what is the data type for these coefficients ABC is a question. So for this problem, it can be either float or double depending upon the problem requirement, right? So let's say now we move to a different problem. So let's say our problem is we want to, there's a polynomial p of x, sigma I is equal to 0 to n, uh, no, ci x power I, right? So now this is the polynomial. How do you represent this polynomial? We need to come up with a representation for this polynomial, right? So Rahul says we, and an array maybe. So Rahul got it right. So we have to use something like, we may use double or float, and then we have a coefficient array, and then we can use n. And then we may also want an additional variable degree to store the degree of the polynomial. So if the degree of the polynomial is 4, then C of 0, C of 1, C of 2, C of 3, and C of 4, they contain the coefficients. So depending upon the degree, some coefficients here have semantics, some other coefficients doesn't have any semantics. So here comes one more important question that like usually when we have arrays, these the size of the array is usually static. So you may use something like 100 here, and no, when we use 100, then you will be able to handle only arrays of whose no only polynomials whose max degree is 99. So there are few questions. I will come to your question in a moment, and so yeah. But on the so later on we will see we can circumvent this problem by using dynamic memory allocation, so that based on the degree of the polynomial we can allocate a suitable sized array. Okay, for the time being we can kind of uh, be kind of get satisfied with this particular representation, but there are limitations to this representation, because we will be able to handle only polynomials of size whose degree is less than or equal to 99 only. Well, there are some approaches without using dynamic memory, but they are not very clean approaches. Like one approach is what otherwise suggesting, and like where you kind of read n and then you declare double C of n. Okay, so this is an approach. So an alternate approach is no, you kind of do a scanf on n and then you do double C of n. This is one approach, but there are other cleaner ways to do it. Okay, sometimes it works, sometimes it may not work, but definitely this is an approach. All right. So there is this question, why do we need two arrays? Like for example, if the polynomial is 6x power 4 plus 1, then the degree of the polynomial will be 4, and the coefficients that we will give will be 6, 0, 0. Like, like this is equivalent to this is equivalent to 6x power 4 plus 0x cube plus 0x square plus 0x plus 1. So you can have 3 zeros followed by 1 stored in the coefficient array. So by taking that approach, we will be able to just use only one array and be able to represent the polynomial. You might be able to come up with alternate representations for the polynomial, but this is one approach to do it. Are you all with me here so far? Doing all right? So now let's look at one more example. Let's say if you're trying to solve systems of linear equations, like 2x plus 3y is equal to 4, minus 5x plus 8y is equal to minus 1. So you want to solve systems of linear equations, and how do we represent these systems of linear equations? What is an appropriate representation for this? 2D array, what will be the dimensions of the 2D array? So one representation is this 2, 3, 4, minus 5, 8, minus 1. And you know that the last column correspond to the RHS. So you have a 2 by 3 matrix. So you can have something like your data type is something like float M 2 by 3. So this is a representation. So given a problem, the first thing that you should do, since you are now looking into problems, so you have some experience writing in programs, the first thing that you should look is, given a problem, what is the appropriate representation for this problem? What is the appropriate model of the problem? And how do you store the model in the computer? Okay. So going back here, So there is a real world problem, and this problem, what is the model of the problem that you are looking for, and what is the model representation? How do you store that model on your system? And once we have the model, we can do multiple algorithmic computations or algorithms on this model. So once we have this thing, so maybe you know, so you have an algorithm which acts on this model, algorithm which acts on this model. So the model representation will have an impact on the algorithm, and the algorithm you have in mind will have an impact on model. So there is a kind of dependency, cyclical dependency between them. All right. Like for example, if you want to think about the cyclical dependency, uh, so if you represent this using a 2D array, then the algorithm kind of has to factor in the fact that the representation is a 2D array. On the flip side, if you have in your mind that you would like to apply a Gaussian elimination method to solve this problem, then you may think the best way to represent this is a 2D array. You all know Gaussian elimination method for solving systems of linear equations? Yes or no? You know it, but you don't know its name. What do you do? So you eliminate this variable, right? So, and you kind of make it into a triangular matrix. And anyway, so that's a different story. But Gaussian elimination method is what you do. That's what you learn. Yeah, echelon form. You kind of convert it into an echelon form and try to solve the system. Yeah. Yeah, making bottom right or bottom left into zeros. Okay. For all the problems, whenever there is a problem that is given to you, so I want you to think about this particular thing. There is a problem, real world problem. What is the model of the problem you would like to have, and what is the model representation, and this depends on what kind of computations you would like to apply on this model representation. All right. So now let's go to, yeah. So in the last class, in the last before class, when I ended, the problem that I gave you is I gave you a problem to sort a list of names. Okay. So the first, how many of you solved that problem? Is there anyone who solved that problem? No one? Yeah, you can use string compare, not a problem. It's fine. So what is the first question you have to ask for that problem? What is the first question you have to ask for that problem? The first question you have to ask for that problem is, how do you store the list of names? That's the question. How do you store the strings? That's the first question, right? So towards answering that first question, I kind of review few ideas which we have seen already in the previous classes, and no, but I'll take it from there. Let me share the screen. Great. So uh, yeah. So what is the, so like for us, so if you take your any computing system, so whatever the variables, the programs, they will all be stored in the memory. Okay, and your memory is a linear array of bytes. Your memory is a linear array of bytes. Uh, I want to review some ideas here before I get started. So the first thing here is, let's say if you have a program, uh, let's see. Yeah. So int num, int star pointer, and ptr is equal to address of num, and you know right. So we have, so what is important here is, if you uh, when you declare this variable num, when we declare this variable num, so and then let's say what num means is, so whenever we refer to num, so the variable num is allocated memory, is allocated 4 bytes of memory. So this is byte 0, first byte, second byte, third byte, fourth byte. So let's say that the base address of the byte, the first byte address is 100, 101, 102, 103. So these 4 bytes are allocated to the variable num. And when we have something like num is equal to num plus 1, then what happens is the data that is present in these 4 bytes, it will be read, we add 1 to it and store the data back into these 4 bytes. And uh, so and then PTR, if you see, and if PTR, it's a pointer variable, and we say we declare it as int star PTR, meaning that PTR contains the address of an object and the type of that object is a integer. Okay, PTR contains the address of an object and the type of that object is integer. So on line number 9, we have PTR is equal to address of num. And if you want to, and if you use star PTR, then what it means is the address that is present in PTR, that is address of an integer object. So read the contents of that integer object. This is what is called as a dereferencing operator. So what do we call num and star pointer? What do we call num and star pointer? We kind of talked about it a few classes back. Otherwise, so there is this question. So int star, so all these things are same. Int star pointer, int space star pointer, int star pointer, all these things are the same. but this is the convention which people use. Okay. So what do we call this num1 star pointer? Will they give the same value? Yes or no? So these two are called aliases of each other. They are called as aliases of each other. They mean one and the same. All right. Do you recall this lecture from which we discussed some few classes back actually? They are aliases of each other. So somewhere down the lane, there is a PTR variable. So this is a sequence of bytes and a PTR variable. And PTR variable contains the address of num, that is, it contains 100. So 100 is present in PTR variable. And when we apply a star operator on PTR, so 100, so when we apply star PTR, then what happens is, so I'm just this, as I told, this is a review lecture. So when we apply star PTR, then we go to the object which PTR points to. How do we go to the object which PTR points to? Because the address is present in this memory. So we go to the location 100, and from that we access. That's what it is. Great. So now I have a couple of questions for you. So let's say, yeah, so here it is what it is. And and then if you, yeah, so now let's take a look at this program. Let's take a look at this program. So here, uh, so in C, there is nothing like a string data type. A string data type is constructed, or no, it's a kind of a implicit, you kind of work with strings by using character arrays. So on line number 6, you see a character array. It's an array of characters. It's not a string. Char name 100, it's not a string, it's an array of characters. So now if you see the memory, so if you see in the memory, so this is the memory. So somewhere in the memory, so this is name, you have an array of 100 characters allocated. Array of 100 characters. And each character takes 1 byte. So you have an array of 100 bytes. A consecutive sequence of 100 bytes are allocated. And what does name contain? The variable name, what does it contain? What does the variable name contain? Let's say the address of this this byte is 100. Then what does the variable name contain? The variable name contains the base address of the array. So if you see on the address of the base address of the array, or no, or the address of this can be name of 0. So this, there can be multiple aliases. The address of name of 0, that is the 0th element of the array, or the base address of the array, they are the same. And if you see uh, the on line number 9, if you see scanf statement, so scanf statement, it has two parameters. The first parameter is %s. So what happens is how in memory, so this % symbol, the ASCII value associated with %, followed by the ASCII value associated with S, and followed by that you will have a null character, because all strings, they should be by default, they will be uh, they should end with null character. So here, so the compiler automatically, when you use double quotes, the compiler automatically puts that null character at the end. But otherwise, if you are constructing strings by yourselves, you have to put null character by consciously, explicitly you have to keep. So let's say the address of this string is 50. So now what happens to the scanf statement? So what will be passed as first parameter to the scanf statement here? What will be passed as first parameter to the scanf statement here? No, the parameter that will be passed is 50. That is the base address of the string %s. The base address of the string %s will be passed as parameter to scanf. That is 50. Are you with me here? Yes, no. The base address of the string %s will be passed as parameter to the scanf statement. Are you all with me? I want to see. This is all. The class is silent today. What is happening? Are you with me? I'm losing you or? Sriharsha, there is nothing like command % getting executed. What do you mean by %? See, when you call scanf, no, there is no task there. You are passing two parameters to scanf. The first parameter is a string, but you don't pass the string as a parameter. You construct a string and the base address of the string you pass as parameter. The base address, look, for example, when you use %s, the %s will be stored somewhere in the memory. This is what is called as a string literal. Percentage is a string literal. Okay, that will be stored in the memory somewhere, and the base address of the string literal will be passed as first parameter to scanf. And what will be the second parameter that gets passed to scanf? What is the second parameter that gets passed to scanf? No, not name of 0, Keshav. It's what is passed will be the name contains the base address. Name contains the base address of the array. The base address of the array is 100. 100 is what gets passed as second parameter to scanf. So now since scanf knows the address of this array, whatever you type on the keyboard, it will be able to write into corresponding memory locations. Whatever you are able to type in at the keyboard, it will be able to store the characters that you have typed in the keyboard in the sequence of bytes associated starting from the base address 100, since it knows the base address. And as it scans, it looks at the format specifier to check what is it expects. Should it expect a string? Should it expect an integer? What is it? It gets there. Are you all with me here on this example? So now let's take a look at line number 15, line number 15, line number 14 and 15. Let's say num is allocated. So somewhere here, like a percent d, and sorry, not percent d. It will not be like that. So there is percent and there is d. Huh. This is danger. And then you have the null character, and this is backslash followed by 0. This representation for null character. Let's say the base address is 150, and then num is allocated memory. This is the memory for num, and let's say the base address of num is 200, and num contains 30. So num contains 30. So there are this 200, 201, 202, 203 sequence of 4 bytes will be allocated to num, and let's say they contain the value 30. So now on line number 15, when we do the scanf, what is the first parameter that gets passed to scanf? So scanf gets passed 150. What is the second parameter that gets passed to scanf? 30. Not 200, because we are not sending address of num, we just put num. So what will happen when we try to do a scanf now? So what will happen? We are passing 30, we are not passing 200, guys. We are passing 30, we are not passing 200. You may get a segmentation fault because the address 30 may correspond to the memory location where flash RAM is present, and you may not have permission to write it. Or it can contain some address where you have the permission to write it, but it will lead to a false program logic. So you will end up getting segmentation fault. With high probability, you will end up getting segmentation fault. But on the flip side, if you have this ampersand num, then what will happen? What do you get? What will you be passing? So if you pass, then instead of 30, you will be passing 200, and scanf will be able to successfully write into the memory location associated with 200 the value that is read from the keyboard. Are you all with me here? Does it make sense why we have to use ampersand symbol in scanf? Now, if you come to printf, so what will be passed here in printf for %d? So what do we pass here for printf? No, first parameter, 150, yeah. So 150 will be passed here. What will be the second parameter? Let's say if you entered the value of num as 45, for example, whatever the value that we have entered on line 15, let's say num contains 45, you pass 45 there, for example. So is it a problem for printf? So there is no problem. So this is in the whole process, whether we are passing the address or whether we are passing the num, the parameter passing mechanism is what is called as a call by value parameter passing mechanism. Call by value parameter passing mechanism. So here, Adarva has this nice question. So hypothetically speaking, let's say we knew the address of num is say 200 and we wrote scanf %d 200. Would we get an error, or would it not give an error? So the compiler may give a warning, but you don't get an error. You can just go ahead and put it, not an issue. It should work. So when we are passing pointers, no addresses, it's a call by value parameter passing mechanism. It's still a call by value parameter passing mechanism. Like for example, here, if you have something like int star ptr is equal to num, and we can kind of here put ptr, will this work or not? Will this work or not? If I do this on line number 16, will this work? It will work. It will not be an issue. Sorry, this should be address of num. Yeah, this should work. Right? But if you want to read something into PTR, will this work? If you want to read something into PTR, will this work? It cannot work because in order to update PTR, we need to know the address of PTR, not the contents of the PTR. Are you with me? If you want to update the variable PTR, we need to know the address of the variable PTR, not the contents of the variable PTR. So, but if you use address of PTR, it will work. Okay. So these are extremely important ideas that I thought I will review in today's lecture. Uh, so a couple of more ideas I want to discuss in the next 5 minutes, and then we can take a break for today's class. That is, uh, in 2D arrays. Okay, so what happens? So yeah, so now we want to work with what data structure we would like to use in order to represent our 2D arrays. Okay, it's not 2D array, sorry, our list of names. What data structure can we use? So while there are few different possibilities, one simple data structure that we can use, is this. Let's go here. So we can use a 2D array. So we can see on line number 58, we have a 2D array. Max length is 100 and max name length is 300. Okay, so this is kind of dumb. So yeah, so let me use maybe maximum max list size. Max, that is, let's say in a class there are maximum of 100 students. Maybe we can use 100 list 100, and let's say the size of the name, the length of each name is 50 max. Then we can have something like this. So you can have so this array, it is a names underscore list. You can accommodate maximum of 100 names, and the size of each name is max 50. So if you look at this data representation, this is a 2D array. So this is a 2D array. This is so this is row 0, this is row 0, this is row 1, this is row 2. Okay, this is 0, 1, 2, and then you can have multiple 50. So like that you will have how many such rows? You will have 99 such rows. And then you will have columns. Okay, you will have all these columns, and you will have how many such columns? You will have I think since we the number of columns is 50, so the last index is 49. So if the first name, let's say if the first name is Om, so O capital M, and followed by that we will have a null character. So this is how the first name will be stored. So in each row we store a character. We store a string or a name. In each row we store a string or a name. Similarly, in the second row we will store a string or a name, right? So what is the base address of this 2D? And then, in memory is a linear sequence of bytes. So this whole 2D structure will be kind of mapped into a 1D linear structure. Okay, like for example, this first row will be stored in the memory, and then followed by that, the second row will be stored in the memory, followed by that, the third row will be stored in the memory. That's what will be done. All right. So yeah, so if you see in the memory, this is your main memory. In the memory, so how many bytes will be allocated for this whole array? How many bytes will be allocated for this whole array? Yeah, 100 into 50, that is 5000 bytes will be allocated. So let's say this is 100. This is the base address of this array is 100, followed by that so on and so forth. So if there are 5000 bytes, then maybe it will be something like 5099 would be the address of the last byte. Okay. So now the question for you is the variable names underscore list. What does it contain? What does it contain? Names underscore list. The variable names underscore list, what does it contain? It contains the base address of the array, so that is 100. This whole 2D array, you store this element here, followed by this element here. You first store the first row, followed by that second row, followed by that third row. And names underscore list contains the base address of this array, which is 100. Okay. And if you want to know the address of the, and you can look at this 2D array as a stack or list of 1D arrays. And what is the base address of the 0th row? What is the base address of the 0th row? How do we get the base address of the 0th row? The base address of the 0th row is, you can kind of say names underscore list 0, 0. Does this make sense? Yes or no? If you take the base address names underscore list 0, 0, we get. And if you want to get the base address of this, of the second array, we get names underscore list, first row, 0th column, so on and so forth. Now we have to use two indices. And in general, if you want to read the ith row, so the base address of the ith row, if you want to get, you can have names underscore list I0. And what will be the address of the element names? What will be the address of the element names, sorry, underscore list ij? What will be the address of the element names underscore what will be the address of this element? You take the base address, names underscore list, and what should we add to this? No. We will add I and we will add j. This is the address. Names underscore list contains the base address. And no, this is not I plus j. This is 50 times I. Yeah, I got this wrong. Because each row contains 50 elements. So we will have I times 50 plus j. So the address of names underscore list is nothing but, computationally speaking, this is what happens under the hood. Are you all with me here? Like for example, if you are in the 0th row, I is equal to 0, right? If you are in the first row, you have to skip the memory that is allocated to the 0th row. So you have to skip 50 and go to the first row, so on and so forth. Are you all with me here on this example? This is a very important example. I want all of you to be with me on this one. Are you all with me here on this one? Yes, no? Okay. So now if you're all with me on this one, now I want you to set up the things for you so that you will be able to write the string sort code for you. Okay. The first thing is this. So in this, if you see, when you want to work with a array of numbers, when you want to work with, not with an array of numbers, you want to work with a list of names, the first choice that you made is this. That is, You are using a 2D array to store the names. You already made that choice. This is a kind of solved problem. The second problem that you have to solve is you should write a routine to read the list of names from the screen, from the keyboard. The third problem is, of course, you have to sort these names. And the fourth problem is you have to print the sorted names onto the screen. So you have to figure out a way to read names from the keyboard, and you have to write a function to print names onto the screen. Now, when it comes to sort, that is task 3. This is task 3. Let's go to task 3. So here, if you go to the sort function, in the selection sort algorithm, what do we do? In the selection sort algorithm, uh, in the selection, so this is this selection sort algorithm, we are working with integers. So you need to change the signature of this sort function. You have to pass the right parameters to it, number one. Number two, we are using this comparison operator. So you have to find a way to fix this one. Okay, how do you compare two strings? How do you check whether one string is smaller than the other string? And how do we do this? Okay, so this is one problem you have to solve. The other problem that you have to solve is, let's say, if one string is out of place, like for example, Banu followed by other is there. So we want to bring other forward and then bring Banu later. So you have to do a swap operation. So how do we go about doing this swap? So to summarize, in order to solve the string sort problem, there are these are the steps that I give you the outline. So the first one is representation. Representation. And we kind of fixated on the representation by saying char names underscore list, okay, 150. We fixated on this representation. The second problem is read names. How do you read names from the keyboard? The third problem is how do you print names onto the keyboard, the list. The fourth problem is how do you sort names. Under the sort names heading, there are sub-problems I would like you to solve. I'm putting them in a different color. The first one is, what is the parameter that you will pass? What is the signature of this function? That's number one. The second problem is, how do you rewrite this code, this if statement that you are seeing here? The third problem is, how do you do this swapping? So all these three sub-problems, they come under, if you solve all these three sub-problems, then you will have your sort names function. I want you to take up this challenge and try to come up with, write a code by yourselves for sorting a given list of names. Are you all with me on this problem? Do you see the big picture? Yes, no, maybe? What does Dhruv is saying? I don't understand that emoji. Is he excited or is he low or is he lost or? Okay. I thought, your eyes are rolling and you're lost. So, okay. Are you all with me, guys? So I think we should stop the lecture here. But before uh, we conclude the lecture, are you ready to take up the challenge to solve this problem by yourself? You got the big picture, right? Okay. All right then. So great. So let's conclude today's lecture here, and we will continue.